we're going to take a look at normal distribution conceptually. You cannot work in education or read about educational research without tripping over this concept of normal distribution. So it's really important to understand. We talk about a curve when we're talking about normal distribution. And that means that in an ideal world, which doesn't exist, your data is going to take on the shape of this curve that we call the bell curve. Across the x-axis, you'd have your scores, and on the y-axis, you're going to be counting how many of each of those scores. And your data will take this shape. If you've got a really, really, really large data set, then you're going to see your scores, for the most part, take on a normal shape, usually. So, for example, these are the SAT scores in 2020. And there were so many kids took this test that they were able to plot the data out. And it takes this shape. You can see very, very, very few kids scored 1,800 points. And very, very, very few kids scored 700 points. And most of the kids scored in the middle. And it takes on this bell curve shape. And there's the mean right in the middle. So there are some characteristics of that normal distribution curve that are really important to understand. First of all, when the data is distributed normally, the mean, the median, and the mode are all at the same point in the scores. Second characteristic is that the bell curve is symmetrical. So the two halves, the half on top of the mean and the half below the mean, are about the same shape. They're symmetrical. Then we keep hearing about standard deviations. So think back to what standard deviations are. And I'm going to use a really fake but ideal data set. It's got 260 students in it. And they took some kind of test in this perfect world. And the mean was 50. And the standard deviation turned out to be 18.75. And I'm going to call that 19, just so that it's easy to add. Okay, so this is the shape that the data takes. There's the mean. And here and over on the right, I've got the data chart. You can see where this information comes from. So there, if you go down to the score of 50, there were 60 students who scored a score of 50. One standard deviation is 19 points. Remember, the standard deviation is 18.75. We're going to call that 19. That means that the score at plus one standard deviation is 69. So you go up 19 points from that mean of 50. You add one standard deviation to it. One standard deviation is 19 points. So it goes right there. So it goes up that's one standard deviation right there above the mean. And we can go the other way too. One standard deviation below the mean, we're going to subtract those 19 points from 50, and we're going to get a score of 31. We can keep going. If we go 2 standard deviations above that mean of 50, we're going to have to add 38 points. And we're going to get 88. And we can go below and take away 38 points, and we're going to get a score of 12. And we can call those z-scores. Remember, a z-score tells you how many standard deviations that point is above the mean. So a score of 88 is a z-score of 2. It also means it's 2 standard deviations above the mean. Now let's look at this area under the curve in that first standard deviation, from the mean up to the border of one standard deviation above it. We're told that 34.1% of all the scores on this test of the 260 will fall in that area of one standard deviation above the mean. Does it? Let's check and see. Okay, so we're looking at all the scores between almost up to 70, 69, and halfway through 50, because you would think that half of the scores in the middle would fall above 50 and half would fall below. So we're going to cut it right in the middle where our mean is. Okay, let's add those up. So there were 60 kids who scored in the 50s, so we want the top half of them, so we're going to take 30 of them. There were 45 kids scored 60, and 69, a score of 69 is not quite 70, so I'm going to say halfway through the 30 kids who scored 70 but not quite, I'm going to say 14 of them. And that adds up to 89 scores in that space, in that one standard deviation. What percent is that? Well, it turns out that it's 0.342, so it's 34.2%. So we came pretty close, just guesstimating. And it works the same way on the other side. We would take this group of scores that are lower than the mean, and once again, about 34% of them are in that first standard deviation. So we can say that 68.2% of all the scores, when it's normally distributed, fall within one standard deviation, either above the mean or below the mean. So often you will see it written out this way. You can see here's one standard deviation, 2, 3, 4, and there's their z-scores. So we say that 68% of the scores, well, it should be 68.2 something, are within one standard deviation, either above or below the mean. Well, when data is normally distributed, you end up with over 95% of the scores within two standard deviations of that mean. So over 95% of the scores are going to fall within those two standard deviations. And you can see that very, very, very few scores, look at where the curve goes, fall within way out at 4 standard deviations either way. So that gives us our bell curve. So those are the 3 characteristics of the normal distribution curve that are really important. But data isn't usually ideal. So what you do is you look at the actual data you've got and you compare it to the normal shape. And you can see in this case, their data is not normally distributed. So you're going to have to do some things statistically when you use that data. You've got to recognize that, because a lot of statistical analysis assumes that the data is going to be normally distributed. Let's look at some shapes. So this would be a normal distribution. The mean and the median and the mode are all right there in the middle, and it looks very familiar. But what happens when it looks like this? Well, there's your mode. That's where most of the scores fall. But That's not the mean, excuse me, that's not the mean. The mean, so many people scored low scores that it pulled the mean down. And now we call this negatively skewed because those low scores took the mean down to the lower end. And what about this shape? There's our mode. That's where most of the scores are. But it's not our mean. More people scored higher than lower, so it pulled the mean over to the right and it positively skewed it. We also have to look at the height of the curve. So this is what we call kurtosis. So this one is normal. This shape is normal. But look at this shape where it's very, very flat. That we call low kurtosis. And then it's pretty obvious that this one, where all the scores are scrunched in towards the middle, that's high kurtosis. And you can see that with low kurtosis, the standard deviations are going to be really large compared to something with high kurtosis, where the standard deviations are going to get really, really small.